Hello, Raman. Let's start our MCQ discussion from question number 21 to 30. This is the third session we are doing, right, with the first tut, right, the workbook 1, right, which is actually appearing in the page number 17, the question number 21. Let's start with that. All right, question number 21, let's start, right? Question 21. See what it says. Which of the following statements is are true for an atom of 118 tin? Okay. So we are looking for the true statement. But we have atom tin 118 and some 50 here, right? This 118 is actually your mass number. Right? Mass number is what? This is the summation of number of protons plus number of neutrons. Mass of atom is due to the protons and neutrons, right? The mass of electrons are negligible, so not that much considering contribution from the mass of the electrons to the mass of the atom, right? So we know that the mass of electron is actually 1 divided by 1840 units of the mass of the proton. So in other words, mass of proton is equal to the mass of 1840 of electrons. So see, so mass of electron is very negligible, right? That is giving no contribution, almost no contribution to the mass of the atom, right? Okay. So here that was the concept of the mass number, and this one representing you the atomic number. Actually, which is the number of protons in your atoms. Right? So you see, if you are to deduct the atomic number from the mass number, that means deducting this number from here, you will get the number of neutrons, right? This clear? Okay. So let's apply the numbers here, right? So this number is given as 118. This is equal to number of protons plus neutrons, and this number is given as 50 atomic number, so that is equal to number of protons. That is what we can gather from the data provided here, right? Okay, so let's approach the question then. Which of the following statement is true for an atom of 18T? It has 50 electrons. So let's copy the statement A, right? So for a neutral atom, right, number of electrons are equal to number of protons. The positive charges are equal to the negative charges, right? Those are the only charge particles there. So number of electrons is equal to number of protons. So here you have 50 protons, so that number of electrons is equal to 50, right? So the statement A can be referred to as a true statement. Right, let's come up with the B statement. It has 50 protons. Is also true, no? Atomic number is equal to the number of protons there. So B statement is also True, right? Statement C. It has a total number of 180 electrons and protons. C statement. So total number of electrons and protons. See. So now we know the number of protons is equal to 50 and number of electrons is equal to 50. We have just calculated, right? So total number of protons and electrons is equal to 100, no? 100, not 180. So 180 is the total for the protons and neutrons, not for the protons and electrons, right? So the statement is false. They are saying 118 of protons and electrons are there. That is false, right? Right. Statement D. It has 68 neutrons. It has 68 neutrons. See, statement D. Right. So 68 neutrons. So if you take this thing as 1, this thing as 2, right? If you are to get the 1 minus 2 from the left hand side, you get 118 minus 50 is equal to, from the right hand side, it is P plus N minus P. So P's will cancel off. So the total number of neutrons is going to be 68. Right? So you can calculate the number of neutrons actually by deducting the mass number by the atomic number. Right? So number of neutrons actually equal to mass number minus the atomic number. Mass number is the summation of protons plus neutrons. Atomic number is the protons, right? That is the idea. So 118 minus 50 will give you 68. Right? If you need a relationship, this is the relationship to come up with the number of neutrons, right? So anyway, the statement is true. They are saying 68 neutrons are there. Yes, that is true. Right? So statement A, B and D are true. That means answer should be answer number 5. He is coming under the A, B, C, D kind of a question. So if the A and B are true, that is number 1. B and C are true, number 2. Right? C and D are true, number 3. A and D are the answers, choices. It should be number 4, and any other possibilities, right? Any other answer is actually coming under number 5, right? So answer is answer number 5. A, B, D are true. So answer is answer number 5. Right? No? Okay, this is the review for the question number 21. Right, now let's do the question number 22. Question number 22, which is appearing at the page number 80. Let's go to that. See what it says. Right. Which one of the following column 1 to 5 correctly matches the name of each scientist in the column with the activities in the activity column? Right. Let's see. Okay, so columns are given and some activities given. Let's discuss about the 3 activities and related scientists, right? So then we can come up with a good answer, right? Activity and a scientist, right? See, propose the nuclear model of the atom. Nuclear model. So which one proposed the nuclear model? It is the Ernest Rutherford. Ernest Rutherford. He was the one who introduced the nuclear model of the atom. Then interpreted the atomic spectrum of hydrogen. Interpreted the atomic spectrum of hydrogen. Right? Who's the scientist? The atomic spectrum of hydrogen is described by, the origins were described by Niels Bohr. Niels Bohr. Remember that? Atomic spectrum, hydrogen atomic spectrum, discuss kare Niels Bohr. That was one failure with the Rutherford nuclear model. Nuclear model was unable to explain the origins of that hydrogen atomic spectrum, right? Then Niels Bohr is the one which gives some solutions, right? So next one, determine the charge to mass ratio of the electron. The EOM, charge to mass ratio, means EOM ratio of electrons. It is J. Thomson, the founder of the electron, J. Thomson. So which column carries these 3 answers in order? Rutherford, Bohr, Thomson. Rutherford, right? Bohr, Thomson. So that is the column 2. That is the column 2. So answer is with the column 2, right? So answer is 2. The column 2 carrying these 3 scientists in order, right? No? Clear? Right. If you need to know about the work the other scientists appearing here have done, Millikan is the one who found the charge of the electron by his oil drop experiment. That is what Millikan done, right? And it comes to Faraday, right? He is the scientist. He was the scientist who had done the experiments with the electrochemical cells and the electrolysis. Right? With the electrochemical cells and the electrolysis, those experiments were done, right? Who had proved that matter is, right, with some relationship with charge, right? Those were some evidence. Matter is interacting with charges, or charges are interacting with matter, electrochemical cells and the electrolysis, and those things were done by Faraday. Those experiments were done by Faraday, right? So those are the things the other scientists appearing in the question had done, right? Right now, this is the review for the question number 22. Okay, let's discuss the question number 23. Question number 23. See what it says. 23rd question. Which of the following statements is are true? Okay. electrons have particle as well as wave properties. We are looking for true statements here, right? True statements. Part A says electrons are with wave as well as particle properties. That is true, no? That is true. Which was actually first suggested by 𝗏𝐵Broglie. Electrons are with both the wave and particle properties, no? Which was first suggested by 𝗏𝐵Broglie. Right? Second statement. A proton is heavier than a neutron. A proton is heavier than a neutron. That is false. That is false. Actually, what you should know is mass of neutron is closely equal to mass of a proton plus the mass of an electron. This is a relationship, right? Mass of a neutron is very closely equal to mass of a proton plus mass of an electron. So that means to the mass of a proton, we have to add some value to come up with the mass of a neutron. To the mass of a proton, we have to add some value, some smaller value to come up with the mass of a neutron. So that means mass of a neutron is coming up with a greater value and mass of a proton is coming up with a smaller value. We need to add some another value to come up with the mass of a neutron, right, to the proton, right? Okay. So mass of a neutron is greater than the mass of a proton. So the statement is false. What they are saying is the other way around, right? Part C. See what it says. All atoms have electrons, protons, and neutrons. All atoms have electrons, protons, and neutrons. That statement is also false. Why is that? Because there is one atom which is not with neutrons. There is one atom which is not with neutrons. What is that? That is the hydrogen. Hydrogen's isotope, right? The protium. The hydrogen's first isotope, protium, is not with neutrons. So the statement all atoms are with neutrons is false, right? Right? Hydrogen's first isotope, protium, is not with, it is protium, protium is this H11, is not with neutrons. Other than protium, all atoms are with neutrons, protons, and electrons. So we have exception here, right? The protium. So as that exception appears, we can't say all atoms are with neutrons. So protium is without neutrons, so the statements had to be considered as a false statement, right? If a statement appears with that term all, if a statement is appearing with the term all, if we have exception, we have to take that statement as a false statement, right? මොකක් statement එකක් තියෙනවා all කියන වචනේත් එක්ක හරි එතකොට මොකක් හරි විදිහකට exception එකක් appear වෙනවා නම් අනිවාර්යෙන් මේ all කියන statement එක false කියලා තමයි ගන්න වෙන්නේ. Exception එකක් තියෙනවනේ. So you can't say all the things follow the truth, right? Okay. Right. Let's come up with the statement D. Let's come up with the statement D. right? So all ions have at least one proton. All ions have at least one proton. This is true. Without protons, you can't think of atoms existing. Without atoms existing, you can't think of ions. Ions are formed by atoms. Ions are formed by atoms, releasing or gaining electrons. In forming ions from the atoms, only what happens is releasing electrons or gaining electrons. Nothing happened to the nuclear particles. Nuclear particles won't change when forming ions, right? So ions are formed by atoms, and all the atoms are with nuclear particles, protons, so that all the ions should be with protons as well, right? Okay. So if you need a review, ions are formed by releasing or gaining. Releasing electrons means positive ions, gaining electrons means negative ions. Electrons. Nuclear particles. That means protons and neutrons are not changing. When forming ions, from atoms. So, as all the atoms are with protons, all the ions also should be with protons. Right now, එහෙනම් හැම අයන්ගෙම protons තියෙනවා. Right now. So that statement is true. So A and D are true. A and D are true. That means the answer is answer number 4. No? A, B true now, answer number 1. B, C true now, answer number 2. C, D true now, answer number 4. Right? A, D true means answer number 4. A, B means 1. It's like A, B means 1. B, C means 2. C, D means 3. And D, A or the A, D means 4. Any other means 5. That is how we are supposed to answer for ABCD questions, right? Okay, as A and D are true here, we have to come up with the answer number 4, right? That is the review for the question number 23 at the page number 18 in your tube, right? Book 1, right? Okay, let's come up with the question number 24. Question number 24. See what it says. Which of the following statement is incorrect regarding isotopes of an element? Right? This is about isotopes. Looking for the incorrect statement. About isotopes, incorrect statement. Right? Okay. See. First of all, let's come up with some properties of isotopes. What are isotopes? Let's learn about that thing bit. then we can think of these properties, right? Discuss about these properties, right? Isotopes. Definition. What are isotopes? Isotopes are different atoms of same element. Same element, right? Which differ as the mass number. Basically due to the number of electrons. Change. Right? So isotopes are different atoms of same element. Same element. Same element means number of protons which is equal to number of electrons are same. Same element means the number of protons, that means number of electrons are same. Right? As number of electrons same means electron configuration. Same. Electron configuration same means chemical reactivity is same. Chemical reactivity is same. Chemical reactivity is same. So with the isotopes, chemical reactivity is same. Chemical reactivity is same. Right? The mass number. So mass number changes because not the electrons, right? Sorry for that. Neutrons change. Yeah? Right? So as the mass number changes, mass number change. So mass number changes means the properties related to mass is changing. Properties related to mass is changing. That means density. So we can say properties related to mass change. What are those properties? Density, which is the mass over volume. Boiling points, melting points. Boiling point, melting point. So boiling point means the temperature you need to supply to convert a liquid to a gas. Boiling point. Melting point means the temperature you need to supply to convert a solid to a liquid. In those scenarios, what happens? The closely bound particles will get apart from each other. When converting solid to a liquid, in a solid the particles are closely bound. When converting it to a liquid, they become right apart from each other, go away from each other. In a liquid, the particles are relatively close compared to a gas. In a gas, the particles are very far away from each other. So there also what happens when boiling is done, that is what happens. There also the particles get apart from each other. For that, the mass matters. For that, the mass matters. If you are heavy, you need to supply great energy as temperature, thermal heat, to put the particles away from each other. Right? So if you are heavy, it's hard to move. No? You need to supply great energy to move the particles, to put them apart from each other. So boiling and melting becomes harder when the particles are with greater mass. So boiling points, melting points depends on the mass, right? So as mass varies with isotopes, the boiling points, melting points will differ. So these are referred to as physical properties. The properties depending on mass are referred to as physical properties. So physical properties change while the chemical properties won't change. So these are chemical properties. Chemical properties won't change while the physical properties will change with the isotopes. Right? That is what you should know about the isotopes, right? Let's go to the sentence one by one to come up with the 4 statements there. Right? First one. The same number of electrons. Same number of electrons. Yes, same number of electrons are there because you are dealing with the same atoms, right? So same elements. So same number of electrons are there. Right? Statement 1. Statement 1. True. Same number of electrons. Statement 2. Same density. No. Density differs. Density differs. That is the 4th statement. Density. Which is a physical property. Property related to mass. Changes with isotopes, right? Number 3. Similar chemical properties. That is true. Chemical properties won't change because same electron configurations are followed by all the isotopes of the same element. So chemical properties won't change. Different number of neutrons. Yes, they are coming up with different number of neutrons. Number of neutrons change. Is true. Number 5. Same number of protons. Yes, same element means same number of protons. This is also true. So you are looking for the 4th statement. That is answer number 2. That is the review for the question number 24. Right? The things are clear. Okay. Right. Let's move to the question number 25. Right. Question 25. Right. See. The number of electrons and the number of neutrons present in 25 magnesium 2 plus ion are respectively. Right. So the question 25, we are looking for number of protons and number of electrons respectively. In what? In magnesium 2 plus 25 12. Right? Okay. Let's come with that. This thing the atomic number is referred to as the atomic number. It is equal to the number of protons in the atom. So that is equal to it. So it is 12. So number of protons in the atom is equal to 12. So one can say number is 12. So 12 is equal to number of protons, right? That is done. Right? This is a charge. This is a charge. The charge of the ion. Charge of the ion. Right? That gives you number of electrons released or gained by the atom to form the ion. This represents number of electrons gained negative charges, right, or released positive charges when forming the ion from atom. Right now? Okay. So 2 plus charge means, so 2 plus means, right, 2 electrons are released magnesium 2 plus from magnesium in forming ion from the atom. Okay, that is what we know about the charge appearing there. Okay, let's combine the two. Let's combine the two. So number of protons are okay, right? That is done. So let's copy the number of electrons, right? So what you know is number of electrons in an atom, not the ion, in an atom is equal to number of protons. Right? So electrons in magnesium atom is equal to 12 as proton number is equal to 8. So electrons in Mg2 plus ion is then equal to number of electrons in the magnesium minus the electrons released when forming the cation. These two. So that is going to be 10. Right now? So this is what? This is number of electrons in magnesium atom. This is the number of electrons released when forming the magnesium 2 plus. Right? So that will give you the number of electrons in the magnesium 2 plus ion. That is 10. So number of electrons are going to be 10, but number of protons 12. So number of neutrons are asked, no? Not the protons. Right? So this will give you the number of neutrons. This is what? This is the mass number. Is equal to protons plus neutrons, right? So that value is 25 is equal to number of protons is 12 plus number of neutrons, right? So number of neutrons here is equal to 25 minus 12, that is 30. So number of electrons are 10, the number of neutrons are 13. So they are not looking for the protons, right? Number of neutrons. Electrons and neutrons, right? Okay. So R should be 10 and 30. First the electrons, no? Electrons are moving on. Electrons, it was neutrons. Electrons 10, neutrons 13. So 10 and 13. The answer is answer number 3, no? Answer number 3, sorry. Okay. Alright. So that is the review for the question number 25. Okay. So complete. Right, let's come up with the question number 26 then. Question number 26. See what it says. Right. Of the following scientists, identify who was not connected with the development of the atomic theory. Right? It's about the development of the atomic theory. Right? Okay. Niels Bohr, Thomson, Chadwick. See, Niels Bohr came up with the planetary model. Right? This model. Electrons are traveling in orbits. Nucleus is there. See, electrons are in here and there. Right? So with that, he introduced the concept of energy levels and the concept of orbits. With that, the quantum numbers, the principal quantum number. This is the contribution from the Niels Bohr to the atomic theory. He was the one explained the hydrogen spectrum as well, right? Niels Bohr. Then J.J. Thomson. He was a scientist who came up with the first model with subatomic particles, plum pudding model. First atomic model with subatomic particles. Electrons are also introduced by him. Electron is found by Thomson. So what was that model looks like? It is the Clump-Pudding model, right? So you have here and there the electrons in a positively charged sphere. Positively charged sphere, the electrons are here and there. Clump-Pudding model. Number 3, Chadwick. James Chadwick. He is the scientist who found the neutron. Found by the Chadwick neutron. Some contribution towards the atomic theory is there with the Chadwick as well. Linus Pauling. Linus Pauling. So we haven't discussed about Linus Pauling yet. Actually, he was a scientist who put forward the electron gravity. That is not a thing related to the atomic theory. Concept introduced. Nothing to do with the atomic theory there. So that should be the answer. That should be the answer there. Linus Pauling. Fifth one, Rutherford. We all know he is the one who came up with the nuclear model. Who introduced that concept of nucleus. And he was a scientist who discovered the proton. Neutron was found by the Chadwick, electron was found by the Thomson, and proton was found by the Rutherford. Contribution was there to the atomic theory. So Rutherford's model was like this. Nuclear model, nucleus was there, electrons are here and there. He was the one who introduced the nucleus. Right? So that is the model, right? So the one who didn't contribute to the atomic theory is the Linus Pauling. So answer should be answer number 4. Answer should be answer number 4. Linus Pauling. What he has done was just introducing the concept of electron. We'll discuss that thing later at the latter section of the unit 1. Right? So that is the review for the question number 26. Right. Let's come up with the question number 27. Question 27. See how it appears. The neutron was discovered by simply James Chadwick, right? Right. Neutron is the chargeless particle at the nucleus, right? So that won't deviate in electric or magnetic fields. Neutron, chargeless, no? Only charged particles will deviate at the electric or magnetic fields, right? Won't deviate at electric or magnetic fields. When it comes to mass of neutron is closely equal to the mass of the proton plus mass of an electron. This is what we have learned up to now about the neutron, and the founder discovered by who? James Chadwick. James Chadwick. In 1932, James Chadwick. Right now, so for the question number 27, the answer is James Chadwick. Answer number 3. Answer number 3. Right? If you need to know about what the other scientists have been done, so we had discussed what the Niels Bohr and Rutherford had done, right, to the atomic theory. So let's discuss about the Albert Einstein's contribution towards science. So Albert Einstein is the one who came up with the concept of photons. Albert Einstein is the one who came up with the concept of photons, right? So he said radiant energy released from metal surfaces coming up as stream of energy packets. Albert Einstein, radiant energy released from metal surfaces coming up as stream of energy packets, which are known as photons. Right? Energy of photon can be found by the E is equal to h mu, right? That is proposed by the Einstein, giving some particle nature, the waves, right? Electromagnetic waves, right? Done by Einstein, and Einstein is the one who proposed the E is equal to mc squared, that world famous equation. That is the most famous equation in the world, right? Okay, that is the Einstein's contribution, right? And Eugen Goldstein is a scientist who proposed the existence of positive particles, positive rays. The positive rays or the positive particles, first, or we can say the canal rays, anode rays. Those were first found by the Eugen Goldstein, right? Okay, so those are the contributions from the other scientists appearing at the page, appearing at the question number 27. Clear? No? Right. So let's move to the question number 28 then. Right. The Plum-Pudding model of atomic structure was put forward by, right? Plum-Pudding model. Plum-Pudding model was done by who? J.J. Thomson. After finding the electron, right? What was it looks like? Plum-Pudding model, right? You had a positively charged hard sphere, right? Positively charged hard or rigid sphere, and here and there electrons are appearing like plums on a pudding, negatively charged electrons which were embedded on surface of the atom, the surface of the rigid sphere. Embedded, right? Not inside, just embedded on the surface. And he further added that as atoms are neutral, right, positive charges are equal to negative charges of atoms, right? So that is also said by the J. Thomson when he was to put forward this plum pudding model. This is the first atomic model with subatomic particles. This is the first atomic model with subatomic particles, right? This is the first atomic model with subatomic particles. Plum pudding model. Right now, there is some review for the question number 28. So the answer is the J. Thomson. Answer number 2. Answer number 2. J. Thomson was the scientist who put forward the plum pudding model. Right? Okay. Right. Let's review for the question number 28. Right? So let's move towards the question number 29. Right? Question number 29. Question 29. See what it says. Green light of wavelength 4.42 into 10⁻⁷ meters is observed in hydrogen spectrum. The energy of one photon of this green light is, right? This is regarding energy of a photon. The question is regarding energy of a photon. So Einstein came up with the equation. What it was that? Energy of a photon is equal to h mu. Is done by the Einstein. The equation came from the Einstein. Energy of a photon is equal to h into the frequency of the radiation. Right? So we know as C is equal to mu lambda. So that mu is equal to CO lambda. So mu is equal to CO lambda if you are subject this thing. So mu is equal to CO lambda. Sorry. You can say energy of photon is equal to h CO lambda. Instead of mu, we just substitute CO lambda. So E is equal to h CO lambda can be used to find out the energy when the wavelength is given. Energy of photon can be found when the wavelength is given with the use of E is equal to h CO lambda. This is referred to as the energy wavelength relationship. This is the energy wavelength relationship, right? This is the energy wavelength relationship. Just apply the numbers to this equation to come up with the energy of a photon with the given wavelength, right? So h is a Planck constant, which is coming up with 6.6 into 10⁻⁻34 joules per second. C is another constant, which is the light speed, which is 3 into 10 power 8 ms minus 1. Lambda. So normally we are supposed to substitute the values for these equations in SI units. So lambda is given in SI units, right? 4.42 into the power minus 7 meters. So if you are substituting the values in SI units, the answer is also coming up with the SI units, right? So we can take this value as 4.4. No worries. Answer to the first decimal is okay, and we as the answers are also given with choices, you can come up with the closest answer there. So this can be taken as 4.4. This is 6.6. So you are dividing by 1.1. So 4 of 1.1s are there with the 4.4, and 6 of those is 6.6, right? So 6 into 3 is 18. 6 into 3 is 18 divided by 4. 18 divided by 4. Divided by 4, right? 6 into 3 is 18 divided by 4. And 10 power minus 10 power values, right? Minus 34 is there. Plus 8 is there. And this minus 7 comes to the top as plus 7. As plus 7. Minus 7 comes to the top as plus 7. So altogether values are going to be 18 divided by 4 is going to be 4.5. 4.5 into 10 to the powers minus 34 here minus plus 15. Plus 15 minus 34 is minus 90. Minus 90. So answer coming up in SI units. Answer coming up in SI units. This is just rough paper, right? Rough. So 4.5 into 10 minus 19 joules. Do we have such an answer? So answers are given in kilojoules. Answers are given in kilojoules. So we need to come up with kilojoules, right? So what we are supposed to do? So to come up with kilojoules, 4.5. So if you need to come up with kilojoules, you need to come up with kilojoules, right? That means if you are supposed to come up with 10 to the power minus 10 to the power 3, no? Kilo means 10 to the power 3. No? So to cancel off that thing, that k, you need to come up with 10 to the power minus 3 as well, right? If you had written 10 to the power 3 here, you need to cancel off that thing with 10 to the power minus 3 as well. So 10 to the power minus 19 is still there. So these two things have been done, right? To cancel off the 10 to the power 3 added there, you need to come up with 10 to the power minus 3, right? To cancel off that thing. So this is how it appears. So the value is going to be then 4.5 to the power minus 19 and minus 3 all to 10 to the power minus 22 kilojoules, right? Now that is your answer. So minus 22 kilojoules there. 4.5 to the power minus 22. So that is answer number 4. Answer number 4. Because the question is asked in kilojoules, right? Not in joules. At the first instance, you get the answer in joules. As you are substituting all the values in SI units, the answer will come up with SI units. But as they have asked you the answer in kilojoules, you have to convert the joules to kilojoules. As you are coming up with some k there, you need to cancel off that k. K means 10 to the power 3. You need to cancel off that k. So you need to come up with another 10 to the power minus 3 to cancel off that 10 to the power 3. Right? So that this becomes 10 to the power minus 22 ultimate. So that is the answer. Or there is a review for the question number 29, right? Answer number 4. Okay. So if you think of other way to come up with this one, so if you are not clear what I have done here, just like this now, so one can do the thing like this as well. E was equal to 4.5 into 10 to the power minus 19, right? In joules, right? If you need to come up with some k term, you need to come up with some k term here. you need to add some k term here. So earlier it was juice, huh? It was juice. So it's like if you need to add some k here, you have to do the change for both the sides, right? K means 10 to the power 3, 10 to the power 3. K means 10 to the power 3. If you multiply with k, you have to do the same thing for other side as well. So again, subjecting that thing, so subject the e again. It's going to be 4.5 into 10 to the power minus 19. This 3 comes to here as 10 to the power minus 3 kilojoules. So this is again the same thing, right? This is again the same thing. We'll give you 22 kilojoules. So you can do like that as well. So, but I prefer this way, right? Little by little, just do the calculations with the use of this method. Okay, so that is the answer to the question 29. Let's come up with question 30. Question number 30. Right? See what it says. The scientist who disproved Thomson's-Lampuny model of the atomic structure is, who is the one who disproved the Thomson's-Lampuny model. Right? This is about atomic models. Let's quickly have some idea about the atomic models, how they evolved, right? So the atomic model started with Dalton, right? Golf ball model. Then, after finding subatomic particles, Thomson came up with Lampuny model. You had a positively charged sphere, and at the surface, electrons were embedded here and there, like this. So this is the Lampuny model of Thomson. Then, this was disproved by Rutherford from his, after he came up with the nuclear model. Introducing the nucleus to the atom. So electrons are appearing here and there. Nuclear model. Nucleus was introduced at the center. Nucleus was introduced. Rutherford's nuclear model. Right, then from this model the nucleus was introduced, right? From this model the electrons are introduced. And then that was disproved by Niels Bohr by his planetary model. There, the orbit concept came to the world. Orbits and energy levels. Orbits and energy levels. Nowadays we know come up with the cloud model, quantum mechanical model, the cloud model, right? This the model from 1926 to now. Schrödinger's model, the cloud model, right now. That is how the atomic models evolved. And the question was asked at this stage: who failed the Thomson's plum pudding model? Yes, that is Rutherford. The scientist who disproved Thomson's plum pudding model of the atomic structure is Rutherford, right? Rutherford. Disproved Thomson's plum pudding model. Right? Actually, by which experiment? The 𝐓𝐴𝐴𝐿 experiment. One can say alpha scattering experiment. So also referred to as alpha scattering experiment. Geigen mass then also helped Rutherford in that experiment, right? So that is a review for the question number 30, MCQ 30 of 38, right now. Okay, let's complete the stuff. So from this one, we are winding up the little session today, right? So this is all about the question 21 to 30 of those MCQs, right? We'll meet with the next session of the reviews of question number 31 to 40. Until then, goodbye.